Hi, everybody. Thanks so much for taking some time off your day to come and listen to me rambling about AI. Couple of notes before we start. So the presentation is going to be shared with you. There's a lot of links in this presentation and additional materials and so on. The goal of today, at least for me, is not to speak the full hour, but is actually just give you, a bunch of like an overview of the work we've been doing, tell you a bit more about the type of people that we are looking for, the job that awaits us in 2021, and kind of get you interested in what we're doing. So at the end, you can ask all the questions you want about the company, the team, the project, and so on. So we're gonna skip over like a lot of details and a lot of things, but the presentation, or you can use Google. There's a lot of information about, like if you want to go deep in some of the project we're gonna mention, and some of the papers and some of the research. There's a lot of information out there. So the fact that I'm not mentioning it today doesn't necessarily mean that there's no materials. It's just that I would prefer to give you a broad overview of what we're doing and where we're going, to see if there's part of this journey and this map that we can explore together. If there's something that you don't understand, as in it's a concept that you have no idea about and so on, please feel free to interrupt me and we can discuss it as we go. It shouldn't be the case, but so pleased to meet you. I'm Jacopo. I used to be the founder of a startup in Silicon Valley. It was called Tuzo. These are my two co-founders. I'm the good-looking one, of course. So we did the startup. That was the plan. Was inspired by South Park, and it turns out to be a pretty good plan. The startup was founded in 2017 and was acquired by Coveo, North American unicorn, in 2019. Tuzo was doing AI and NLP for retail, so mostly e-commerce, and we're going to talk a bit more about that. Coveo basically does the same thing on a much larger scale. I'm now the lead AI scientist of Coveo after the acquisition of my company. Coveo is one of the biggest AI employer in Canada, even in North America, in the non-public company space, of course, excluding public companies. The company raised more than $300 million in the last 2 years and a half. We have almost 600 employees right now and more than 1,000 customer deployments. So today, what I want to talk about is what I call AI for reasonable companies. What does it mean? Well, you probably know, as well as I do, that there's a lot of hype and a lot of discussion about AI in the media, and there's a lot of, like a reasonable number of cool things that happened in the last couple of years in AI. If you are as old as I am, and you've been doing this before it was cool, you cannot but rejoice, to the fact that the world kind of caught up with the idea that building, intelligent machine is a pretty cool thing. And if you see around, you see like AI is the new electricity. If you didn't know the story of AlphaGo, I strongly suggest the documentary. There's a link to this. And of course GPT-3 and all the things about natural language generation and so on and so forth. Elon Musk, which says sometimes is known also for claims that they're not necessarily super accurate, but it thinks that AI will overtake humans in less than 5 years. And everybody says that the market size of AI is going to be worth almost $1 trillion in the upcoming days. I mean, this is a huge thing. This is like an incredibly big thing. If you look at today at the top 10 companies by market cap in 2020, the majority of that are actually incredibly vested in this whole AI and data business, right? If you see on the right here, Apple, Microsoft, Amazon, Alphabet, Alibaba, Facebook, Tencent, and also Visa are actually pretty, at different levels, but they were actually all pretty involved in this AI thing. In the e-commerce space, which I know very well because I built a company in that space, innovation is usually done by the usual suspect. In fact, if you go and check, all the major e-commerce track at the best conferences in computer science, like KDD, GAR, ACL, blah, 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 there was like a total of 41 institutions and 28 from industry and 13 academia. Out of 28 institutions, only 2 companies were not public. That means that the vast majority of the research at cutting, like at the top of the field, is basically carried out by these companies you see on the right, or a variation of this company. Like for example, Netflix is not on the right because it's a comparably small company, but it's still a giant, public company. And there are only 2 companies that have been publishing in this space in top conferences without being a public company. One of them, of course, it's Coveo. So why is that? Well, there's kind of like this idea that AI is, the AI that you see in the news and that you read on Wired, on Fortune, is actually a pretty expensive thing, right? So AlphaGo, which is of course a shiny example of incredible AI system, was trained on like 500 million games, something like that, which is the equivalent of playing for 500 human years. And it costed an estimate of 20 million US dollars in electricity alone, like basically server cost. If you think about GPT-3, GPT-3 is this amazing, it's really amazing. Like, I don't know if you have tried, but it's really amazing. This really amazing language model by OpenAI was, again, just training that costed 20 million dollars, which is a lot of money. If you read the original GPT-3 paper, which is very cool, there's a bunch of things here and there that are like, well, we would like to run this experiment, but we didn't because it costed too much. So we're at the point that even when we publish a paper, in NeurIPS or ACL or whatever, there are some experiments we cannot really be asked to run because they're too costly and too expensive. So I mildly disagree, with all this view that only gigantic and super rich company can actually do meaningful AI work. I mildly disagree with that because I actually think that interesting AI work can be done at mostly any scale. You don't need to be an OpenAI or Google to do some interesting AI that have some real challenge, both on the theoretical side, as it is an intellectual challenge, and also on the applied side, as in you're actually going and influence people's life. When you actually do interesting AI, there's a bunch of things that you need to do. The first one is, and we're going to discuss about that, you need to be really good at data engineering. This is very undervalued in the field, as everybody wants to do model, the saying, everybody wants to do model work, nobody wants to do data work. But data work is actually 95% of your job, which I know it sounds trivial, but it is. Like if you know how to get data, architect data, engineer data, that's incredibly more valuable than building a model. You have to be good at programming, of course, and you need to be good at what I call model thinking. Model thinking is a phrase taken from Scott Page, a guy from Santa Fe Institute, which is the idea that you need to be able to formulate models of reality. So you kind of need to treat hypotheses and building AI system like a scientist kind of thing. So it's this idea that having a research attitude, as far as curiosity, as far as rigor, as far as testing, is good even if you're not doing pure research job. And to prove to you that you can do interesting AI at a reasonable scale, I'm going to present to you one actual case from our recent past. And I'm going to guide you to all the choices that we made in doing that to give you a feeling of what it means to work in this setting. All good so far? Anybody has any question, doubt, clarification? All good? Okay, I'm going to continue. So you probably familiar with this website, which is Amazon, which is like a small company in Seattle selling books and now selling also other stuff. If you search on that, like Galaxy, and you're gonna get some results. But of course, if you logged in, because Amazon typically have customers that have been always logged in and then buy a lot of time. So this is my co-founder Ciro. When Ciro searched for Galaxy, the results, as you can see, actually slightly change. Why that happens? It happens because Amazon has kind of a profile of what you like, and based on your previous behavior, your past purchases, and so on and so forth. So he's able to actually influence in real time the ranking of their system based on what they know about you. So it's like a paramount example of good AI in information retrieval. So what is the problem? Well, this is Leroy Merlin. Leroy Merlin is not a small company. Leroy Merlin is European Home Depot. They make $22 billion a year, so like a reasonable amount of money. But they're not Amazon, right? So Amazon have 220 million, I think, users a day, something like that. Leroy Merlin is like roughly 1 million. So it's still like a very important site, but it's not even close to the to the same amount of people that goes on Amazon. And a problem that people have when they're not Amazon or eBay or Rakuten is that people do not really come back to the same shop. What does it mean? Well, you're used to this Amazon experience. When you go back, you're always logged in and Amazon knows everything about you. But in the vast majority of e-commerce, when people like runs a shop, a digital shop, they have the problem and people go there, they don't log in, they just, start browsing, random stuff. And if they don't find what they want, they're just gonna leave. And maybe they're never gonna come back in the next 6 months or so, which means that the vast majority of people are not actually recurrent users. So if you're building a digital shop and you're on Amazon, you can't really assume that people are gonna come back, which means two things. First, if you want to give the personalization thing that Amazon gives people, you need to do that with the least amount of data possible. Because, well, you never know if the person is coming back, right? There's no person here that's going to give you this entire history of purchase that you can learn from. You actually have to do it basically on the fly. The second natural consequence is that now personalization become a session-based inference. A session, if you don't know what a session is standardly defined, Google Analytics standardly defined as, any event that happens within 30 minutes from each other. So if you open a website, you start browsing and then you click on stuff and then you add stuff to the cart, that's a one session. If you go away, stay away for 31 minutes and you come back and you keep on browsing, that's another session. The idea is that the general partition, like the most important partition for personalization, is not really the entire history of a user, because most users don't give you a history. It's the session, because people need to have a good impression as soon as they touch on the website. So how do we solve this problem? If we cannot brute force this problem like Amazon does, just relying on the fact that people are logged in all the time and that people buy stuff on Amazon every 3 days, how do we solve this for a typical retailer? Not a small one, like even people making billions of dollars a year, but not a humongous retailers. Well, we need to get creative, right? So the way in which we solve it is by building what is called a product space. What is a product space? Well, if you think about a catalog, so this is a sport apparel retailers, and this is like an example of what happens when you read a catalog of these retailers. As you can see here, it's very easy to interpret for like humans, right? So you have different items. Items that have properties like the brand, the price. In this case, a sport retailer, so you also have the sport. So you have a racket, which of course is used for sport tennis. And then you have a pair of sneakers, which are used for basketball. And then you have a pair of soccer shoes used for soccer, and so on and so forth. When people start browsing in an e-commerce, what they do is basically they go from one product into the other. That's a very familiar experience. You probably do the same when you shop on Amazon or whatever or Nike, whatever you go shopping. So there are two anonymous users here, user A and user B. We have pictures here, but remember, we don't really know who these people are because they're not logged in. So pictures are just for the sake of exposition. We don't really know anything about these people. And one user is browsing, female tennis stuff, and the other user is browsing basically male soccer things, right? And this is what happens while they're actually doing that. And of course, we want a smart system to kind of guess that, right? We want a smart system to know that the user on top is a tennis fan and the user at the bottom is a soccer fan. How do we do that? We do that by basically projecting down products into a product space. And we do that with an algorithm called prod2vec. Since I don't know if you know what word2vec is, we're gonna spend 2 slides on word2vec. If you know what that is, it's gonna be a rehearsal. If you don't know what that is, it's a tiny new thing that you can learn. So how do we go from what people do in a session to basically a product space? There is a multi-dimensional representation of this product, what is called an embedding space. We do that by leveraging the same intuition that we leverage in NLP, so natural language processing, for words. If you know a bit the history of NLP, you know that for a long time, people in NLP used to represent words is what is called the one-hot vectors. So for example, let's say we have 4 words here: dog, cat, roam, and play. And you can see here, these are 4 vectors that are basically all 0, except they're 1 in one position, okay? And this is a way in which you can feed words to computers because, as you all know and very well, or computers do not really like words, computers really like numbers, okay? So the way in which we tell computers what are words is basically by mapping words to these vectors. There's a bit of problem with this representation though. Well, there are actually 2 problems. First one is kind of a big impractical because you can immediately guess that, the more words we have, the bigger this vector will become. So it's not like super, it's like a super efficient. And second, it's very hard to guess which words is similar to which other words, because there's no way for me to look at the vector of dog, cat, roam, and play and to get any idea about the underlying meaning. So what people in NLP did is came up with an idea, which is called word embeddings, that kind of solve with these two problems with one model. So what they do is a way to embed, that is to push this, incredibly high dimensional space, a space that is as big as the vocabulary, okay, into a very, very, very small space, let's say a 48, 50 dimensional space, okay? And the idea here is that once you map all these spaces, well, all these words into this space, words that are similar meaning, are actually end up very close into the space. Words that are far apart in the space, it means that are words that are completely unrelated to each other. This is based on what is called the distributional hypothesis, right? Which is the idea that words that are similar tend to appear in similar contexts. For example, cat and dog tend to appear in sentences like the cat is on the mat or the dog is on the mat, while, I don't know, Rome and Berlin tend to appear in similar sentences like Rome is the capital of Italy and Berlin is the capital of Germany, okay? This is really the equivalent of the old saying, you know a lot about a man by the company he keeps, right? So it's the idea that similar words tend to appear in similar context. When you take a word embedding of normal words in the English vocabulary and you project them down in 2 dimensions just to show them, this is a real plot on the right here. You can see here that I color-coded words by the type, right? So there's like general words, which are the black one, which are unnamed. And then you can see some categories that I singled out. You have pronouns, you have cities, you have countries, you have food. You see here that the algorithm is very good at actually basically clustering together things that are related to the same topic. Not only that, but topics that are related to each other, for example, cities and countries, the green and the blue one, are way closer to each other. For example, the cities and food, okay? So this is very handy, and this whole idea of embedding words has been one of the 3 or 4 key ideas in NLP in the last 10 years. So it's very important. How do we build this, nice space when everything is close together? Well, we need to do 2 things. First, we prepare a corpus that is, like a long list of English sentences. For example, the cat is on the mat, the lion is hungry, and so on and so forth. Very practically, this is basically a list of lists in Python, if you're familiar with Python. And then what happens is that basically we train a very small neural network whose task is to predict a word given the surrounding word, that's it, right? So in the case of the cat is on the mat, we give to the system as input the is on, so the same sentence without cat. And then we train the model so that it tries to predict cat instead of the or angry or some other word. The cool thing about this is that once you train a model to do this, you can completely forget about the prediction that is about the last part, and you can take the weights of the model in the middle as a dense representation of our vocabulary. I know it sounds like, if you never heard about this, it seems like a bit of a magic. So it's a very convenient way of getting stuff. It actually is. But there's extensive knowledge and literature about this. So this is an example here. If you Google online word2vec, you find like 25,000 tutorials. But the whole idea here is that we go from a very, 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 very big, sparse and discrete space, which is the word in English, to a very small, dense, and meaningful space that is neural network friendly. Well, what is the relationship between words and product? Well, remember the idea that people in a session go from one product to the other? Well, that's kind of the same idea as the word in a sentence, right? Actually, you can go from word2vec to what is called as prod2vec, prod as in product, by basically substituting the idea of words in a sentence, like the cat is on the mat, with product in a session. So if instead of giving the algorithm that we saw before as input a list of words, you give a list of products that people click when they actually go on a website, you're going to be basically able to train a prod2vec space. This is a real space in 3 dimensions of a sport apparel e-commerce. Each dot here represents a product in this 3-dimensional space, and products are color-coded by the sport, by the reference sport. So for example, the green one is soccer, the violet is running, and so on and so forth. As you can see here, again, the algorithm is pretty good at clustering together things that are the same color, meaning that just by observing the behavior of basically people online, just by basically taking sessions of people online, we're able to build a good representation of products in the space. If you go and see where are these items, you can go from the items that we saw in the beginning, which is the catalog as humans would read it, to the representation that the machine has of the catalog, which is this one. is a space where products occupy different regions. So if product occupy a different region, then what is a user? Well, a user that is browsing a website is basically a user that is walking in this region, right? Again, this is very familiar with the geographical space, right? If you go on vacation in Hawaii, in Honolulu, or if you go on vacation in Aspen, Colorado, I can tell a lot about your preferences just by knowing where you're going on vacation. This is exactly the same thing. So user one is walking part of the space, which is the tennis part of the space, okay? And then user two is walking the part of the space, which is the soccer part of the space. While never labeling as the tennis part of the space or the soccer type of the space, the machine is actually implicitly knowing which are your preferences as you basically browse a website, okay? So different users walk in different regions, as well as different humans go on vacation in different places, and you can tell a lot about what they like by this this intuition. All good so far? Any question? Good. Still good. I don't see the chat from here, so if you have a question in chat, I can see them. All good? Okay. So now that we know how to teach what a session is to a user, what can we do with it? Well, we can build a lot of stuff, and I'm going to just single out one of them as a clear example of what you can do. You see here, again, this is Amazon, of course. When you start typing stuff on Amazon, what happens is that in a lot of cases, you will find not just a suggestion, which is called the type add suggestion. Nint is going to Nintendo Switch, but we're going to get a category after that. So you can search Nintendo Switch, not generally in all the catalog, but in a very specific category, which is video games. This is helpful because if you have a very, very, very big catalog, it may mean that Nintendo Switch may end up all over the place. So your search results may actually be pretty dirty. So a good system is a system that nudges you as soon as possible into selecting the category you want to actually use. A key point about products, when you actually look at a real catalog, is that products are arranged in what are basically taxonomy trees, right? So again, go back to our sport apparel example. This is of course, a simplified version of the catalog, but as you can see here, different hyperlinks correspond to different position in the tree. And again, this is very intuitive, right? So there's a part of the apparel that says sports stuff, and sports differs for basketball and soccer, and within basketball, you have shoes and basketballs, right? On the apparel side, for example, here we have jacket and pants with different products and so on and so forth. So what we want to do as a feature is we want to replicate the Amazon behavior. That is, once you type, we want to suggest you a category, okay? But with a twist. We just don't want to suggest you a specific category. That is, for example, go back here, I don't know, soccer, okay, or jacket. We want actually to suggest you the full tree. So we want to suggest you like a list of ordered nodes in this tree so that you can decide a different level of depth where you want to actually be. And we have two inputs in this system. One is what you're typing. That is, in this case, of Nintendo or shoes, if you're searching for, I don't know, shoes for LeBron James. And you have what we call the session vector. What is the session vector? Well, remember the session that we saw before. The session vector is a way to represent the session of people as a walk into the product space. How does this model look like? Again, this is very kind of hand-waving. There's a full paper about that, but just to give you an idea of how we put all this idea together. So we have a way to represent the language, which is a dense neural network. And then we have the proto-vec that we saw before. There is a representation of the products. We basically concatenate that into an encoder according to the wide and deep approach. And then we have a decoder, which is an LSTM. And the LSTM job is to basically unroll one step after the other these nodes in the hierarchy of product. So as an input, you get words and product vectors. As an output, you basically get a tree that is unfolds dynamically. Does it work? Well, we compared this idea of how to build this type I categorization tool to a simple count-based model, which is a discrete model that is not using any personalized information. It's just basically using the past behavior of user and clicks to do a prediction, and a simpler neural network model that is a perceptron that is smaller and faster to train than the full encoder decoder. but it's still like a neural network that can take advantage of both the context of the query and the query itself. This is just the accuracy at different level of depth. And then you can see here SP, which is session path, is the name of the algorithm, is significantly superior basically to any of the tested alternative. Does it work? Well, this is a real example from the system when it's been trained. So this is a user that is typing N, and one of the suggestions for the user is Nike shoes for men, which is a very reasonable suggestion. And now the question for the system is, what is the category we should suggest for this to the user? And as you can see here, so when there's no session, so on the left, when there's no session, when the user hasn't clicked on anything before the query, there's no product, so we don't know where is it on the space. You get the most, the most common possible suggestion, which is shoes, sneakers, men. If the user has actually used a running shoes before, you see that the prediction of the system immediately changed to sport running shoes. Okay, and then if the user saw these basketball shoes, the system is not confident to make any prediction, so the system actually doesn't output any prediction. If you see below, the second line, the darker gray, is the same system, but when the confidence, when we call the confidence threshold is slightly lower, which means that the system is encouraged to be a bit more aggressive in making prediction. So when there's no session, the prediction is the same. When there's the running session, as you can see here, the system is making a longer tree prediction. You see here that the path that is suggested is a 4 nodes path and not a 3 nodes path. And the funny thing is that this is actually wrong, because this shoes is not an A3, is an A7, so which it's a very peculiar thing that I didn't know before working in this space. But it's interesting because even if it's wrong, it's still a very good guess. Like it's still a very reasonable guess. And of course, on the right, you see that the user, when prompted to be a bit more aggressive, is correctly suggesting sport basketball shoes as a possible category for a user that has been showing interest in basketball product. So even on a qualitative perspective, so this is just one example that we single out, but there are many others, we also know that this system may work actually very well. If you want to know more, well, again, this has just been a bit of rushing through all the concept, but I wanted to give you this end-to-end feeling of how a product and business idea comes together with some modeling idea and then some testing and qualitative result. There's a paper from last year. It's called How to Grow a Product Tree. There's a blog post with an open source version of the code using Ludwig. Ludwig is a deep learning toolbox by my friend Piero Molino from Uber, now from Stanford. So we rewrote basically the model for the paper. We rewrote it using Ludwig, and it's open source. So if you want, you can actually go online and see all the details about this. Of course, well, this is not the only thing you can do with the product space. Remember the nice product space idea when people, when shoppers are basically conceptualized as travelers in this space, where there's a lot of things you can do. This NLP thing that I just showed you is like a tiny, tiny thing of what has been done in this space, even just last year. So these are other papers that our group published last year in top conferences, and that result either in interesting theoretical results or very practical feature for our product. One is the fantastic embeddings paper is about making inference from one shop to the other. So if you have two shop and two product spaces, how do you travel from one to the other? Shopping in the multiverse is a paper about causality. It is how do you use machine learning to understand causes, not just correlations. And the Rex's paper, the embeddings that came in from the cold, is a way to address the cold start scenario. If you're not familiar with the cold start scenario, is the problem that people face when products, in this case, have no interaction or no history to learn from, right? So machine learning, of course, is very good to learn when there's a lot of history, but what can you do when a product is new? What can you do if a product is completely without any interaction? And our Axis paper actually addressed that. All of these are linked, so when you get the paper, when you get the presentation, you can obviously Google them, but you can also click on that and you get all the full papers about that. Some of them also come with open source code. As we said before, I really do believe that you don't need to be Google to do interesting AI work, but I do believe you cannot do it by yourself. Like it really does take a village. And from our side, we're a smallish company compared to public giants, But we have a network and an expanding network, hopefully also thanks to you. We have an expanding network of people in North America and in Europe that work with us in different projects and different problems and different features of common interest. So one of the strategy that the team has is partnering up with researchers, professors, students from different institutions, and work together to get something that is basically mutually valuable. So last year on the left, this is all the people that somehow were able to be involved in our work and publish things with us from all sorts of institutions. So Bocconi and Queensberry in Europe, Microsoft Research in Canada, Stanford and Uber in the United States, and so on and so forth. And on the right, these are the conferences where we published last year, either theoretical results or applied results, sometimes the main conference, sometimes workshop papers, and so on and so forth. You probably know all of these conferences. If you don't know this conference, these are the type of companies that are with us on stage when we go and present our work. And so we're very proud to be the smallest guy in the room. So we're very proud that even if we're very, very far from being, as rich or, as big as Amazon and, and Google Brain, that we can go on stage with researchers from this institution and present our ideas. And we look forward to do more of that. All good? So,
question on context. So for example, if I were to recommend ice cream, I might eat the same kind of ice cream every day. But shoes I may buy once a year. So if I had bought shoes recently, I may not want to recommend that again. In fact, this is a pet peeve of mine. Every time I search something, for example, I search Coveo, and then Coveo ended up all over my Facebook feed. So it's sort of this, very simple, it's almost not predictive. It's like, repeat what you just told me you wanted again and again and again and again and again. So do you have anything dealing with sort of the context that is maybe it's raining outside and so you may more want an umbrella today, or you just had shoes, so maybe you want to go to the second or third product kind of thing?
Nice, thanks for the question. So a couple of things. Yes, retargeting is the worst. I think is the worst as a user, is the worst as technology, and I don't really understand how is that so much economically valuable. But yes, retargeting really sucks, but I don't know anything about that. What I do know a bit is about like recommendations and personalization. And typically, like if you went to an e-commerce and bought a pair of shoes, even Amazon tends to suggest you more shoes, which is still mind-blowing consider the amount of data and the amount of sophistication that they have. So the so-called serendipity effect, if you guys want to search for that, discoverability or serendipity are sometimes what is used in the industry to address the fact that people want a more diverse set of results, not just more of the same than what they just bought. On our side, most of the work has been done on users that we never see again. So the fact that you buy shoes is at the end of a session, and hopefully I was able to influence you because you were looking at soccer shoes in the beginning. So I'm able to change your experience in such a way that at the end you're gonna buy shoes. And then if I don't see you again for a year, I'm fine with that. So most of the work that I've been doing, at least in last couple of years, has been on session-based stuff. So if you leave the website, or if you come back after 3 months, I'm basically treating you as a new user. So the only thing that I care about is what you're doing right now, not what you did last time, which I understand is a problem of its own. It's a simplified assumption, but like a huge part of visitors never come back. So.
Thank you.
Of course. So what are we doing this year? Well, we're doing a lot of cool stuff, and I just put like a bunch here to get you an idea of what we would like to work on with people, researchers, professors, students, and so on. So knowledge graph is surely like an interest of mine. We like to explore how to mix structured entities and unstructured data in a unique form of representation. Structured entities are typically what a knowledge graph is made of. I don't know if you're familiar with the concept. It's like the idea of concept together, and so on and so forth. But we also want to do unstructured data. For example, if I have a text message, I can put it as a structured entity in a graph because he has an author and he has a and he has, somebody replies to that if it's a Slack message, but it's also as a content, right? So how do I represent the content of this message in this graph, right? Do I do topic modeling? I don't know. Do I do some kind of embedding? Blah, blah, blah. We have an activator research in recommender system, and in particular, in the idea the recommender system can be improved with tools from cognitive sciences. There's a longer scientific discussion to be had here, but if you're familiar with NLP and language models and so on, a lot of things with NLP have been doing in the last couple of years is a lot of success, but basically disregarding everything we know about language, like everything. Like everything we've been known for thousands of years about language has no place in current NLP, which is probably a stupid thing. Recommender system is the same. Recommender system are basically built on variation of the idea of matrix factorization, and that kind of disregards everything we know about how people make decisions, for which we again have entire disciplines that are devoted to study that. Microeconomics is surely one, psychology of decision is another one, behavioral economics, and so on and so forth. So one of our theses is that we should be able to build a better recommender system if we just look at what other sciences have been doing instead of just basically doing matrix factorization in one flavor or the other. On the data engineering side, we have huge fan of improving data tooling for people doing machine learning. I just published like literally today blog post and code for people that want to use Metaflow. If you don't know what Metaflow is, it's a Netflix tool for machine learning stuff, and I strongly suggest you to look it up. And we want to do more research on how to do what we call pass ML engineering. That is ML engineering without deploying any server. I strongly believe that productivity for machine learning people is basically is inversely related to how many machines and how many infrastructure you have to manage. Ideally, you shouldn't really manage any infrastructure, and infrastructure should be managed for you by other systems. And so we're investing a lot in that. We're doing some NLP research on lexical learning. Lexical learning is the problem of, let's say you have a search engine and I search for raffle, and I don't know what raffle means. So how do I learn the meaning of raffle in a fashion e-commerce, right? How does the system know the meaning of raffle without asking a human or without waiting to see 25,000 million people like looking for raffle? And then we have a bunch of other stuff. If you want, we can talk about more. What do we have to offer? Well, we have a lot of data, especially in commerce, meaning tens of millions of events per day, billions of events in a year, and everything standardized, normalized, and rich and available to you to state-of-the-art system. In our case is Snowflake. Again, if you don't know Snowflake, check it out. Amazing. We have a very open data culture, as in we work with people from universities to share our data and publish together and do research together. And we constantly try and open source data. We open source 5 million of events, anonymized events, like a couple of months ago, and we're gonna likely, this is unofficial, but we're likely to release 30 million of events in the next couple of months of real people making purchases online. So this can be used for personalization, for recommendation, for all sorts of user studies, and so on and so forth. And we have all of that. And of course, if you work with us, you have full access to all of that with a very light agreement, which is basically a standard NDA that, kind of like, if you respect the data and, how important these are and, the anonymity of all of it, you can get access to a lot of data. And of course, we also have information about catalogs and products, right? Remember the products that you see that every day, our clients send us a version of the catalog that they have, which means that for every day, we have exactly all the information about a product. What can you do with that? Think about prices, right? I don't know if you know that, but prices in any commerce change continuously, right? Maybe by a small amount. If you can trace back all the changes that the prices of a given product has had in the last couple of years, and then you mix that information with the amount of people that visit the product, buy the product, and so on and so forth, you can think of doing cool stuff like estimating demands or making dynamic pricing and so on and so forth. And all of this information is basically at your fingertip. What are we looking for? Well, generally speaking, fun people to do fun stuff with. More specifically, we want students or recent graduates that want to join our ranks and kind of help us with some of the things that I said before. We typically have 2 paths, and then yes, we still have I think we're perfectly on time. And then I conclude and wait for your questions. We have typically 2 paths and 2 ways in which we can join us. One, which is an internship, which is a limited amount of time, is typically 2 to 3 months, and you work on a specific project with us. Specific project typically takes two flavors. One is a research project, which is, remember some of the nice, crazy idea that I just said 1 minute ago. You can join us and help us developing that. And, in all likely, we're going to do some cool stuff. And, it may be that we publish something in a cool conference together. So we go to the conference, we give our talk, we add one line to our CV, and we kind of know, if you're new to this, you work with people that have extensive years of experience in research from different countries and different topics, and you may learn how to write a research project and so on and so forth. So I think it's a good learning experience, but the outcome of this is not a practical thing. That this is in one form or the other, a paper or research notes or something like that. Or you can do an applied project, which is help us building out what we do for a living, right? Which is cool products that hundreds of millions of people use every year, okay? It doesn't mean that it's not, cutting edge, but here the focus is more on the engineering side of it, right? So the final goal of this type of internship is to build stuff that people use, okay? So to push things, maybe open source, it may not be open source, maybe for us, it may be for the community, but it's mostly getting your hands dirty and trying to understand how to build a feature end to end. So what you're learning here is not so much how to write a research paper in a top conference, is how to take a business problem, like the one that we saw before about personalization, and you kind of know all the people and all the small knob that you need to fix for that idea and that business problem to be solved in modern software development. By modern, I mean, I think we use, pretty state-of-the-art tools in all our stack, Snowflake for data warehouse, dbt for transformation, or like, other DAG type of transformation. I don't know if you're familiar with that, DAG type scaler like Airflow, Prefect, and so on and so forth. And of course, all the latest Python libraries if you want to do ML, and Python framework to do serving and so on. For Python framework, we use Fast API. I don't know if you know it, it's very cool. We used to use Flask, but we moved to Fast API very recently. That's path number one to work with us. Internship, typically in one of these two things, and then we can discuss exactly what, but that's path number one. Path number two, we are also growing aggressively as a company. And so we keep on hiring people in our R&D department, which is now more than 200 people. Okay. We hire at all levels of seniority, and we also hire at kind of like junior-ish level of seniority. And in particular, in this moment in time, data engineering for us is a very important part of the company, and we are hiring aggressively in that. So we're looking for people that have some experience with AWS and basic idea about cloud infrastructure. So, what is Kafka, what is service, what is Kubernetes, what is serverless, like bunch of basic experience in our cloud infrastructure work. And of course, coding abilities in Python, and maybe also Java, Golang, depends on what you are. So if you feel that you already, you already have what it takes, and you have enough experience, or not you, but maybe a friend that recently graduated from this program, or whatever. But if you feel that you don't need an internship, you don't want an internship, but you think you're ready for the full thing, please drop me a message, because we're really looking for people that feel this role. Okay, and the easiest way is for us to have a chat with me first, and then if we think it's a good fit, we're gonna send you to HR, and that there's of course hiring process that is highly standardized and so on and so forth. But it's way easier to get into the process if you go through me than if you just answer to the to the website. That's my point. And of course, and also talking to me, you probably kind of, we can just avoid everybody wasting time if it's not a good fit, or on the other side, you can streamline the process if we believe it's a particularly good fit. So this is the second part of the offer, okay? You can refuse. It's not like The Godfather if I'm Italian, okay? So you can refuse. But yeah, the point is internship on one side, way less demanding, but still pretty cool. And you can maybe write a dissertation or whatever you want for it. And then, doesn't mean that one can turn into the other, right? It doesn't mean that you can start with an internship and then we both like each other so much and you get a job offer at the end, right? Or the other part is, if you've already done an internship or you're at the end of your program and you want to try and do this for a job, and you think our company is cool enough and what we do is cool enough for you, drop me a line and we can explore that. So I hope to have been reasonably clear. You have all my contacts, and you can drop me an email anytime or add me on LinkedIn or something like that. Again, the presentation is going to be yours, but please now ask me everything you want to know about the team, the company, the project, whatever you want.